Good morning, AP Micro students. This is Miss Beck coming at you from my living room on day 4 of the quarantine. Happy Thursday. So let's take a few minutes and revisit some of the things that I don't think we're quite getting from looking at you guys' work. So we're going to revisit our cost curves. I think part of this is we've been so focused on the tables and not the curves themselves. So let's look at the curves. Again, this is kind of reviewing those modules 52 through 55, which we've been hanging on to this past week. So sometimes in the AP FRQ, they will ask you to draw cost curves. And if they ask you to draw cost curves for a firm, please note that the y-axis is your cost and your x-axis is your quantity output. The other thing to make sure that you know is that marginal cost curve is going to be that lovely Nike swoosh shaped. So your marginal cost curve is that lovely Nike swoosh. Remember, marginal cost is change in total cost divided by change in quantity output. And so far, pretty much everything we've done, our marginal or quantity output's been 1. Please note, if you ever see a table, it may not actually be the case. But again, change in total cost divided by change in quantity output. Your ATC curve is kind of U-shaped, and it is at its lowest point where it crosses the marginal cost curve. Remember, average total cost, it's total cost divided by the quantity. Now, where it intersects with MC at its lowest point, that is what we often refer to as least cost output. So that is the output where it's costing you the least to produce it. Here, I'm just rolling on with it. Here, your average variable cost goes down till it intersects MC. Again, average variable cost is at its lowest point where it intersects MC. And then it starts getting closer and closer as it goes up to the ATC, but it never intersects. So it gets closer and closer, but it doesn't intersect because technically you've got the fixed cost in between those two. Remember, fixed cost is the difference between average total cost and average variable cost. That's your average fixed cost stuck in there. But you'll often see your average fixed cost right here in another curve. So your average fixed cost is decreasing the entire time. Remember, it's the average of a fixed cost. So regardless of the amount that you're producing, that cost doesn't change. So as you're dividing it out, so fixed cost divided by your quantity of output, that number is going to get smaller and smaller. So let's say here it's $100 fixed cost divided by 1 unit of output. So 100 divided by 1, it's 100, but let's say here it's 10 units of output. 100 divided by 10 is 10. You can see that's getting smaller as you go along. Now, sometimes you are asked to find total cost, variable cost, or fixed cost, and you're given marginal cost, average total cost, and average variable cost. And you're like, there is no way I can find that from the information that I'm given. Well, actually, yes, there is. Because remember, an average, it's the total divided by quantity. Well, here you've got to reverse that. So a lot of times what they'll do is they'll give you a question with cost curves, and they'll say, at a quantity output of 8, what is the total cost of production? So what you're going to do in this case is at that output, and let's say it's 8, you would draw a straight line up. And where that line intersects your ATC curve, or your average total cost, draw it over to the cost axis. So here you have 8, and then you would times it times 4. So 8 times 4 is 32. And that tells you your total cost for producing 8 units of good. To get the average variable cost, you would do the same thing. You would take it up to the average variable cost and over, let's go with that at 3. So 8 times 3 is 24. And fixed cost, you would do the same thing. So 8 up to where it intersects the fixed cost, and then over is 1. And so is $1, so 8 times 1 is 8. Now, your average fixed cost and your average variable cost should add up to your average total cost. So we said this one was 24, This one is 8. 8 plus 24 should equal then 32. So if you have a question like what is the total cost, or what is the fixed cost, or what is the variable cost, and they give you cost curves with averages, now you know how to solve those problems. Another thing that we touched on briefly but haven't talked a whole lot about, and we need to, is the relationship between marginal cost and marginal product. Remember, marginal product is the change in total product divided by the change in the number of inputs, like the number of workers. So what we're trying to find with marginal product is how much additional output is each additional worker generating. And so from this, what I have is I have the marginal cost curve on the top and I have the marginal product curve on the bottom. And marginal cost and marginal product are mirror images of each other. So they should be related. If you're using the same data, they should look relatively related. So basically what's happening, I'm going to look at the marginal product first, is as you increase the number of workers, initially, as you increase the number of workers, they're able to produce more than any of them could produce on their own. So it's what we call specialization. They're specializing in their work, they're doing better, they're increasing productivity, and they're increasing productivity at an increasing rate. And that's why we see marginal product initially go up. So due to specialization, they're able to increase productivity or increase output at an increasing rate. But then you reach a point where each additional worker is contributing less and less to the total output. And this happens because you have fixed resources and you reach a point where more workers just kind of get in the way. And you're going to have social loafers who aren't working as efficiently as others. You're going to have competition over those fixed resources or factory size, or they get in the way, or someone goes off into the bathroom and is talking on their phone. So each additional worker is contributing less and less to total product. And so this is where diminishing marginal return sets in. So through this area right here, we have something called diminishing marginal returns, where each additional worker is producing less and less output, but they're still producing total output, which we'll get to in a minute. Now, from here, you can see that due to specialization, our marginal cost actually decreased initially. That's why we have that lovely Nike swoosh. So initially, as our marginal product increases, our marginal cost actually decrease. Basically, each worker is contributing more and more, meaning each additional unit of good is costing them less and less. But when each additional worker gets less efficient, that's when the costs start increasing. So it's costing the firm a little bit more per each additional unit of input because they're producing a little bit less output. And again, when marginal product equals 0, that is when it's actually each additional worker is not contributing to your total product. Your total product is actually decreasing, so their quantity output is not helping you any at all. But this center section, really quickly, this center section is where diminishing marginal returns is happening. Now let's look at this with total product. I've been kind of teasing you on that. So what we see here with total product is in this stage 1 returns. Your marginal product is increasing and your total product is increasing at an increasing rate. So again, your workers, as you add the first couple of workers, due to specialization, they're able to produce a lot more than they could each produce individually. And so your total product, the amount of output that each input is producing more and more and more. But when marginal products hits its peak and starts to go down, what we're going to see is our total product still increasing, but it's increasing at a decreasing rate. So this is what we often say where diminishing marginal returns occurs, or stage 2 returns. So marginal product is decreasing, but it's still positive. It's still above 0, which means we're still producing, or now total product is going up. So marginal product is decreasing, but positive. Total product is increasing, but at a decreasing rate. And when marginal product goes to 0 and negative, that is when total product is now decreasing. So each additional worker is costing you more and more to produce. They're not worth having at all. They're costing you money. And this is also, you can see this on a table. So again, stage 1 returns. This is where marginal product is increasing and total product is increasing, and it's increasing at an increasing rate. Stage 2 from a table, this is where marginal product is decreasing but still positive, and total product is increasing, but it's now increasing at a decreasing rate. It's not increasing as quickly. So marginal product, each additional worker is producing less and less additional output, but they are still increasing the amount of output being produced. So marginal product positive, total product increasing at a decreasing rate. And then when we get to stage 3 returns, we see marginal product is negative or has gone negative, and we're actually losing total product. Now, this is just a quick overview of some of the things that we've talked about. Tomorrow we will start talking about Module 56, which is about costs in the long run. I hope this helps. If you have any questions, please don't hesitate to send me a text via a remind or email. I'll talk to you later.